In this lecture, I'll introduce Bada's runtime namespace. The runtime namespace includes classes related to the timer, threads, and thread synchronization mechanisms. We will discuss each class in more detail in the following slides. The timer class facilitates you to perform operations based on timeout events. Threads are the means for optimized resource utilization in Bada and must be synchronized while accessing common resources among different threads. Let's have a look at the timer class first. The timer class notifies an object of a timeout event when a specified period of time has elapsed. The timer class has the construct, start, and cancel functions. In the construct function, you can add a listener object to receive a timeout event when a period of time has passed. In this way, if the event listener is defined in the construct function and the start function is called, the timer starts. You can define the timeout duration by specifying the start function parameter in millisecond units. To stop a running timer, you can call the cancel function. The timer class calls the onTimerExpired function of the event listener object after the period of time specified in the start function. Attention! The Bada timer is a single-shot timer. It fires a timeout event only once for each call to start. So if your application requires a repeat time, you can restart the same again in your onTimerExpired callback method. Okay, let's have a look at the timer sample code. This will give you a clear idea of how the Bada timer works. The code is part of a program that performs an operation every 10 milliseconds. First, to perform the operation every 10 milliseconds, the foo subclass of the iTimer event listener has been defined, which handles and receives timer events. Then, the start timer function is implemented to start the timer in the program. This function constructs the timer, adds the listener, and then calls the start function. For this start function, the timeout parameter has been set to 10, so that the onTimerExpired function is called after 10 milliseconds. The onTimerExpired function performs the operation and then restarts the timer operation, so that the onTimerExpired function will be called on again. Next, we'll have a look at Bada's thread class. Threads are basically used to create multiple control flows that can run simultaneously within a single process. In Bada, there are two types of threads. One is a worker thread, and the other is an event-driven thread. In general, while a worker thread is created to perform relatively long operations in parallel with the main thread, an event-driven thread is created to handle events independently from the main thread. Therefore, an event-driven thread can be implemented using an asynchronous call, but a worker thread cannot use an asynchronous call. The iRunnable interface facilitates defining a task for a worker thread. This iRunnable interface is the base class of the thread class and has a virtual function, run. You can create a worker thread by implementing the code in the virtual run function. The class derived from the iRunnable interface is the thread class. The thread class has the onStart, run, and onStop virtual functions. Let's see how a worker thread operates. If the main thread constructs a subthread and calls the start function of the thread, the onStart virtual function of the thread is called, and then the thread enters the run state. The run function is also a virtual function that the developer should implement. You can implement any operations except asynchronous operations to be performed by the thread here. The subthread will terminate only after the rum method returns, or the exit method is invoked after the onStop callback gets called. Let's see how an event-driven thread operates. If the main thread constructs a subthread and calls the start function of the thread, The onStart virtual function of the thread is called, and then the thread enters the run state. The run method of an event-driven thread has its own event loop and shouldn't be overridden or implemented. You can implement any operations to be performed by the thread inside the onUser event received N method. While the subthread is running, if the main thread calls the stop function of the subthread, or the subthread gets terminated, then the thread stops and the onStop function of the thread gets called. Let's take a look at how to create a worker thread. First, I'm going to show you how to create a thread using iRunnable. As you can see in this example, the subclass of iRunnable has been specified in the aTask class, and the run function has been implemented. You can directly specify the operation that should be performed by the thread in the run function. To use iRunnable, create a new thread in the main thread or subthread, create a task, and then add the task to the thread. If the thread is started, the default implementation of the onStart function is called, and then the run function in the iRunnable is performed. As the main thread and the child thread works asynchronously, it is always recommended to adopt the safe deletion of a child thread. Applications need to ensure that a child worker thread has completed its task and is terminated. The join method will make the current thread wait until the child thread is completed and terminated. This sample code shows how to use the thread class by inheriting the thread class. In general, to use the thread class by inheriting it, you have to implement 4 functions. The first function is the construct function. In the construct function, you have to set the thread to be either a worker thread or an event-driven thread. The next function to be implemented is the onStart function. The onStart function initializes the thread. The next function to be implemented is the onStop function. The onStop function is called when the thread is terminated and returns all the resources created in the thread. The last function to be implemented is the run function. The actual operation of the thread is implemented in this function. In case you require to terminate or exit the thread currently running, you have to call the exit function of the thread. This sample code shows how to call the thread that was created in the previous example. You need to create, construct, and then start the thread. Then the thread enters the run state and executes the thread's main body. After the run method returns or exit is called, the thread terminates. Ideally, the thread instance should be destroyed only after a thread is terminated. The join method makes the current thread wait until the child thread is terminated. So, for the safe deletion of a worker thread, it's always recommended to perform the thread join operation. This event-driven thread sample code creates a thread that performs an operation periodically by using the timer event. First, the class corresponding to the thread inherits the thread class and the iTimer event listener class, because the class should use the timer event. In the construct function of the class, the thread type is set to an event-driven thread. In the onStart function of the thread, the timer is constructed with this object as the listener parameter. After that, the start function is called with the timeout parameter set to 10, so that the timer calls the onTimer expired function after 10 milliseconds. In the onStop function, the code to stop and delete the timer has been implemented. In the onTimer expired function, the operation to be performed periodically is implemented, and the start function of the timer is called again, so that the onTimer expired function is called repeatedly. Since this class is an event-driven thread, the run function is not implemented. You can use the event-driven thread from another thread in the same way as a conventional worker thread. Event-driven threads facilitate sending user events to the child thread and handling them through the send user event and on user event received N methods, respectively. Next, I'll talk about the classes related to the synchronization between threads. Bada provides the mutex, semaphore, and monitor classes for synchronization. The mutex class limits access to a resource shared with threads so that only one thread can access the resource at a time. The semaphore class limits access to a resource shared with threads so that only a specific number of threads can access the resource at a time. The monitor class is for managing a critical section. This sample code shows how to synchronize the variable count using a mutex. As you can see in the last part of the code, the main thread creates a mutex. If a thread needs to access the variable count, the thread must acquire the mutex first. As long as the mutex is acquired by a thread, other threads cannot acquire the mutex. Then, the value of the variable count is changed and a mutex is released. Then another thread can access the variable count in the same way. At this time, when thread A acquires the mutex and thread B attempts to acquire the mutex, the acquire function does not return until thread A releases the mutex. Therefore, only one thread can access the variable count at a time. This sample code shows how to use a semaphore. A semaphore is intrinsically similar to a mutex, but you can specify the number of threads that can access the semaphore data simultaneously. In this example, the semaphore has been set to the variable count. As you can see in the last part of the sample code, the number of threads that can access the data is specified when the semaphore is constructed. In this sample code, only one thread has been specified to access the semaphore. As you can see, thread A acquires the semaphore, accesses the variable, and then releases the semaphore. Thread B is implemented differently from the one in the previous sample code. The parameter 10 that is specified when the acquire function is called indicates that the function should return if the semaphore cannot be acquired within 10 milliseconds. When the function returns a value corresponding to success or not successful. If the returned value is not successful, the corresponding operation is to be performed, since it indicates that acquiring the semaphore has failed. If the returned value is successful, the thread can access the shared resource since it indicates that the semaphore has been acquired. This example shows you how to order jobs using the monitor. As you can see, thread A performs jobs 1 and 2, and thread B performs job 3. At this time, if job 2 in thread A is to be performed only after job 3 of thread B is performed, thread A can call the wait function for the monitor after the completion of job 1. The wait function waits and does not return until the notify function of thread B is called. Therefore, if this code is performed, the order of the job execution would be 1, 3, 2, or 3, 1, 2, so that job 2 is performed after job 3 without failure. Now, let's wrap up this lecture. Bada supports multi-threaded applications. There are worker thread types and event-driven thread types. You can create a thread-safe application using synchronization functions such as mutex, semaphore, and monitor to protect resources shared by multiple threads.